As we turn our attention to the user interface portion of the architecture that we've been developing this semester, I want to spend a little bit of time just kind of talking about that in a little bit more detail. We've covered some of these ideas, the idea of AJAX and stuff, but I wanted to drill down into that in a little bit more specificity. So here's some comments about user interface architecture. So by way of introduction, again, I want to remind you of kind of what happened between what we now typically refer to as kind of Web 1.0 and Web 2.0. So in the olden days of the web, the 1.0 era, the browser was basically kind of a passive mechanism for displaying information received from the server and for sending information to the server based on user input. But the process of making a connection to a website would start with the browser just sending the initial URL to the server, and then the server would receive that request, and it would figure out what page was being requested. That might be just a static content, an HTML page that had already been created. It might also make use, for example, of some kind of a templating mechanism, or it might just be straight up server-side code that generated the HTML. It's also going to be executing business logic or application logic, right? Making sure that if, say, the user had submitted a form or something like that, that the contents of that form made sense. It might talk to the database if necessary to satisfy that request. And then it basically sends back to the browser the entire HTML page that the browser is going to display. And then on the browser side, again, it's going to display the HTML. It's also going to handle any forms that might be part of that new HTML page. Is, for example, a sign-up form or a login form, or maybe a add product to shopping cart form, whatever that happens to be, or handle any kind of buttons that are present on that page or other links. And then it's going to send a request to the server again. And then after sending that request, it's going to have to sit there and wait for the same basic process that we just described here under the server portion. And when the server comes back with that new HTML page, the browser will replace it. So the chief user interface and user experience challenge with this kind of an architecture is it's kind of a one page at a time sort of a thing. You do one thing on the web page, and then there's this delay while the request associated with that action goes back to the server. The server takes its time to develop a completely new web page, sends the entire page back to the browser. The browser has to display the whole thing, potentially losing sort of context information and just making the user experience a lot less robust. So it was a great start to web applications, but not particularly sophisticated. With Web 2.0, which was the kind of inaugurated by the introduction of this technology that we now refer to as AJAX, things got quite a lot different. AJAX, as you recall, stands for Asynchronous JavaScript and XML. And it was actually introduced in a column by a guy called Jesse James Garrett. I don't know if he's actually named after the gunfighter, but there it is. He's the guy that kind of put the pieces and parts together and first expressed this as a coherent idea. When he was doing that work, XML, which stands for Extensible Markup Language, was kind of the standard format for interchanging data between computer systems and computer programs in a lot of different areas. It actually, if you look at XML, it looks a whole lot like HTML, and in fact, both of those are kind of descendants from another kind of markup called Standard Generalized Markup Language, or SGML. A nice way to think about XML is it's sort of like HTML for data. You can, instead of being restricted to a particular vocabulary of tags like you are with HTML, right? You've got the head and the body and title and H1 and H2 and P and those kinds of tags, right? HTML defines a specific set of valid tags. XML allows the end user to define what the structure of a document might look like, which means that you can make it essentially a container for any kind of information you want to transmit back and forth. So that made it really a handy tool for doing this kind of data interchange. So that was what was kind of all the rage at the time that Jesse James Garrett cooked up this AJAX idea. In practice now, a lot of the data transfer that goes back and forth between client and server, between browser and web server, is going to be JSON strings. And that's going to be the case for us in here as well. So you should be aware of the existence of XML and kind of where the AJAX acronym came from. But in practice, you very seldom see that used, certainly for new projects. So under this paradigm, the Web 2.0 paradigm, the browser can still request an entire page, right? The first time you go to a website, you are going to get all of the HTML necessary to display that from the website's homepage and so forth. And this is kind of like the Web 1.0 model, where you make a request, you get that whole page. You click a link on that page or click a button on that page. You may still end up going back to the server, having the server cook up the entire page as a response, send it back to the browser, and display a completely new page. What AJAX allowed, instead of that kind of page at a time approach, was to let you to request sort of subsets of the page. So for example, if you had an e-commerce page that had, the header and the menu bars and the graphics and today's specials and all that kind of stuff, there might be an area on that page that might display, for example, your current shopping cart. That might be, a table that's embedded inside that HTML. And when you updated your shopping cart, added a new item or something like that from a form at a different part of the page, the AJAX mechanism would allow for the client, for the browser, to just say, hey, here's an update to the shopping cart. And then on the server side, you'd process that update and send back information that could be used to just update that one section of the page. So if the shopping cart's occupying, a third of the page area, and the remaining 2/3 is just kind of, wrapping and styling and headings and that kind of stuff, only the portion of the page containing the shopping cart would need to be updated. So the browser at that point could kind of just sort of swap in a different table, and that new information would be updated to reflect the change to the shopping cart, but none of the rest of the content of the page would change. So it gave a better user experience for two reasons. One, you kind of maintained the context of the page on which you were working. And two, when you requested additional information, you actually didn't have to send quite as much stuff. If all you're updating is the HTML for that table and not the CSS styling, not other graphics that are on the page, you're going to get a snappier response from the server side because you're sending fewer bytes. And again, as we've been talking about all semester, this request is asynchronous, right? So you can still interact with the other things that are available on that HTML page while this AJAX request is taking place in the background. The first A in AJAX, literally stands for asynchronous. So we got two things going on at once. We can still keep the user interface going, but we can also be doing something behind the scenes to fetch back information from the server side. So much richer approach to application development, better user experience, better performance, just kind of generally better overall, I guess, except that it's more complex, but that usually comes hand in hand with improvements in the technology. So here's a illustration from that article by Jesse James Garrett. Over here on the left-hand side, what he calls the classic web application model, we've got the browser up at the top here, and it's sending an HTTP request to the server, and the web server is going to receive that request, do all of the back-end stuff that it needs to do, like talk to databases, process that page, interact with other systems, formulate a response, which is going to take the form, usually, of HTML and CSS, also maybe images and some JavaScript and stuff as well, and that's what's going to get transmitted back to the browser. And what Jesse James Garrett is proposing here for the AJAX model is quite different. We've still got the user interface in the browser, but now the user interface, instead of making an HTTP request like here, we're actually going to call some JavaScript code. And the JavaScript code is going to invoke functions in what he called here the AJAX engine. So this is just basically JavaScript code that's running on the browser side that knows how to interpret this information. What it does is it sends an HTTP request, like in the 1.0 era. This is Web 1.0. This is 2.0. So that HTTP request comes across. And this similar kind of functionality takes place on the back end. There's going to be a web server that's going to receive that request, decode it, figure out what kind of information the browser is asking for, go out to the database, legacy systems, and other things to formulate that response. But what it's going to send back in this version in true AJAX, what it's going to send back is some XML. So it's data, not markup or styling or JavaScript. And then the AJAX engine on the browser side is going to know how to take that XML data and turn it into something that's going to then finally be used to modify the HTML or the CSS on that page to update the user interface. So in the case of updating a shopping cart, the request that goes across to the server is going to fetch up the current values in the shopping cart, and the information that goes back is just going to be those data that correspond to the current contents of the cart. And the functionality defined here as AJAX engine, which again is just some JavaScript, it's going to parse this XML data and use that information to update the information being displayed on the page by changing the HTML, updating the CSS, that kind of stuff. So it's a big step forward from the 1.0 to the 2.0 model. It's still a little bit user interface centric in a sense, but the basic focus here is quite close to what we're going to be using for our application. Another way of viewing this, if you think about kind of the interaction between client and server, between browser and server, this would be the classic approach, the 1.0 approach, and this would be the 2.0 approach. The classic approach, we've got client here and server here, and time is increasing across the page. So what's going to happen is a kind of a strict back and forth between the client and the server. So there's some user activity here that takes place in the browser. Maybe the user fills out a form and clicks the submit button, and that's going to result in information being transmitted to the server to give it information about what was put in that form with a post request usually. And then the server side is going to do some processing. Meanwhile, the user interface is pretty much just inactive, right? We're blocking the user interface while we wait for the server to respond to us, which is something that we now know is just sort of anathema in application architecture. We don't want that user interface to go dead for this period of time while we're waiting for the server to respond. And eventually, the data is returned from the server, and now the user interface comes back to life again, updates itself with the new data that was received, and allows us to interact with it again until such time as we do something that requires another trip to the server, at which time the user interface is going to go dormant again. In contrast, on the 2.0 view of things, we're going to have, you'll notice here that instead of having the user activity arrows being sort of split up, we've got a nice continuous user activity arrow. We can continue to interact with the browser because all of this interaction with the server is going to take place asynchronously, behind the scenes, in another thread. So the user interface code never stops running. But at whatever time the user interface is asked to get more information from the server, that creates a new thread, essentially, right? What's called here client-side processing. So this is another thread of control that's running in the browser, and it's responsible then for sending the request and waiting for the server to respond and getting the response back. So at whatever time this response comes back to the client, to the browser, at that point then, the client-side processing code can go ahead and make an update to the user interface. In the meantime, the user interface continues to function normally and allow the user to interact with it without any awareness really, other than maybe just a delay in updating the user interface, that multiple things are happening here simultaneously. So again, this is not probably new. We've talked about these ideas before, but just wanted to refresh your memory, maybe give you a little bit different way to visualize these two approaches to application architecture. Now, the current state of the art is what it goes by different names. It's still considered sort of Web 2.0, but here we're thinking about a specific kind of an architecture for what's happening on the browser. And it's usually called a single page application. Some people call it a rich internet application or an RIA. There's different words for it. But we're basically saying here is that we're going to press this AJAX idea to its logical conclusion. So instead of having, still quite a lot of application functionality taking place on the server side, we're going to try to push as much of that as we can up to the client, and then only rely on the server side to supply us with data. So the application is going to be basically running entirely in the browser. We're going to have this one chunk of application code that's going to be downloaded to the browser, and that's pretty much the way things are going to stay for the duration of this application. We're going to continue to interact with the server to get data, but all the code, at least in principle, has been sent to the browser. So at the time the application starts up, the browser's still going to send an initial URL to the server, right? Take me to your home page. But what's going to come back from the server now isn't going to be just the initial HTML. It's actually going to return the code that's going to run in the browser for the duration of the user's interaction with that website. So it's going to get some JavaScript code. It's going to get some HTML, some CSS that's going to be used to style the user interface. It might get other assets like fonts or images, logos, that kind of stuff that's going to be used repeatedly across the browser application. After that initial delivery of all of that content, that the application itself, the browser kind of goes into more of a steady state mode. It's not fetching a bunch of new information from the server all the time. It's basically just running the code that was delivered in the startup phase. So the browser's running that application, and the application is using these AJAX kind of ideas to request information from the server as required. And notice that it's requesting data, not HTML or JavaScript or anything like that. It's just interacting to get data from the server. So this is where our RESTful API comes into the picture. All of the information that the user interface running this single page application is going to have access to is going to be delivered over the RESTful API, and it's going to use JSON instead of XML, as we've been talking about. It's going to use JSON as the format for receiving information from the server, as well as for sending information to the server when we want to, for example, post information about a new entity that needs to be created in the database. And then the server's job becomes a little more focused, right? It's not any longer trying to supply the entire content of that web page to the browser. It's only responding with the data that's needed, so that the code that's running out there in the browser, this JavaScript, has information necessary to update the user interface as appropriate. Now, there's a variety of different approaches to creating these single-page applications, and what I want to consider here is what are usually called frameworks. We'll see that there's kind of three big dogs that are in the marketplace right now, and I want to talk first a little bit about kind of why you might choose one over the other. So this is not just specific to user interface, but just kind of a general idea about how you approach learning a new tool or whatever. So this idea of cognitive load is an expression essentially of how hard or how easy it is to learn and use some tool. Cognitive load is a more general term than that, but that's kind of what we have in view here. If we're sitting down and trying to make a choice between one of three, say, user interface frameworks, which one do we want to pick? Well, ideally, we'd like to have one that results in fairly low cognitive load. It's easy for us to learn, it's easier for us to understand, it's easier for us to debug, it's easy for us to teach others on our team how to use, that kind of stuff. And it also, if possible, leverages things that we already know. Right? Learning a new thing is easier if we already know kind of the fundamental underlying concepts that are necessary to understand that new thing than if we also have to go back and learn all of the additional prerequisites for that, right? It's kind of like the way that your college courses stack up. So we'd like to have low cognitive load when we choose a new tool that we're going to use, if possible. Sometimes there isn't an option and we just have to sort of bite the bullet and learn. But if we have a choice, which we do, we can choose partly based on cognitive load. The other criterion that is, I think, important when making decisions like this, and again, this isn't just specific to or limited to just user interface technology, but anytime we're choosing a tool, and that's something that we do all the time in computer science, certainly, there's kind of two ends of a spectrum here that we could think of as opinionated versus indifferent. So some tools, some frameworks, some languages fall more on the opinionated end of the spectrum. And what I mean by that is that the designers, the architects of that framework have just decided, hey, you're going to do everything the way we say you're supposed to do it, or it's stupid to use our tool, right? It's kind of an our way or the highway kind of an approach to things. And if that's sufficient to the needs and the requirements that you have around the use of this tool, that might not be a bad thing. In a way, we could think of Happy, our application server, as a pretty opinionated framework, right? There's a very specific way that we need to write routes and handlers and what we have to return from those handlers and that kind of stuff. It kind of gives us a roadmap for how we should interact with that server or that framework. And if we diverge from that or try to kind of violate those assumptions, we sort of open ourselves up to more complexity, more difficulty. So I don't want to suggest that opinionated is necessarily bad, but it's something that you want to be aware of, right? Does this framework require us to use all and mostly only the tooling and the capabilities that come with that framework? Or are we on the other end of that spectrum, what I've called here indifferent? And I don't mean that to be pejorative again. I just mean to say that the framework is available. It does maybe one or two things. It does those things really well. And if you want to use that in conjunction with other tools that you may be familiar with already, or other things that you want to learn, or things that are on the horizon, it's easy to kind of hook together the indifferent style framework with those other pieces and parts. Now, I would argue that if we go back here and kind of think about the cognitive load associated with these two approaches, the opinionated type of framework is typically going to have a higher cognitive load. If you're not already familiar kind of with the basic paradigms that an opinionated framework takes on as representative of its architecture, you got to learn a bunch of new stuff. And you might not actually have prior knowledge about some of those assumptions. So, although, again, it's not necessarily bad to use an opinionated framework, I think it's important to recognize that in some cases, depending on the background that you have or that your team has, it might be more difficult for you to bring into the development practice because there's sort of a higher cognitive load. On the other hand, an indifferent framework tries to be really, relaxed, tries to be really chill about what it is you've got to bring to the table. Use this to solve this one problem and make use of all the other knowledge that you already have, and we'll try to play nicely in that sandbox. So from a cognitive load point of view, I think the indifferent framework is kind of a win. Another dimension that we want to consider when we're choosing among different frameworks, again, not just UI frameworks, but that's what we're thinking about here, is comprehensive versus interoperable. So a comprehensive framework is one that tries to provide all of the pieces and parts that you could ever need in order to do this particular thing. It's often referred to as the batteries included kind of an approach to things. Happy, again, as it's an opinionated framework, it's also it attempts to be a comprehensive framework. So it's got routing, it's got database integration, it's got error reporting, it's got error handling, it does all sorts of stuff, security, authentication, authorization. Those are all kind of wired into the Happy ecosystem. Now, that's in some ways a very compelling value proposition, right? You don't want to have to go and figure out how do you hook up all of those different kinds of capabilities that I just listed by using different tools and frameworks and libraries and stuff to come up with a coherent whole. The architects of Happy have already done that for you. It comes with all the pieces and parts. It comes with the batteries. The other approach, on the other end of that spectrum, we could refer to as interoperable. In other words, something that's designed not to just assume you're only going to use its ecosystem, but that it's going to be able to work in a friendly and capable way with other kinds of tools, other kinds of frameworks, and so forth. That seems sort of more flexible, but the downside is it usually requires more thought about integration. So if you're trying to do the moral equivalent of an interoperable application framework instead of Happy, well, what are you going to use for a web server? What are you going to use for database access? What are you going to use for object relational mapping? How are you going to report errors? How are you going to do authentication? How are you going to do authorization, right? All those things that you're going to eventually have to add to a production quality application now kind of fall more in your lap because you've got to now choose the pieces and parts to interoperate with the framework that you've chosen. Whereas on the comprehensive side, you have a lot more of those decisions that are just kind of made for you. And if the choices that had been made by the architects of that framework are okay for your application requirements, that's great. If they're not, kind of a problem. Again, I want to ask the question of kind of where's the higher cognitive load? And I would also suggest here that the interoperable has a lower cognitive load. When you think about a comprehensive framework, now you've got to learn and understand the entire thing in order to be able to make uses of the various pieces and parts. The interoperable approach does require more thought about how you're going to integrate that with other pieces and parts. But if you've already, for example, got a comprehensive solution for, say, server-side stuff and how you do authorization and authentication and whatnot, you might find it easier to adopt an interoperable framework. So Okay, and we're going to take a look at some of the specific frameworks here and then look at that along these dimensions as a way to kind of move in the direction of choosing one. So here's the kind of the three most popular user interface frameworks for the JavaScript ecosystem. They're Angular, which is from Google, React from Facebook, and Vue, which is actually not associated with any organization like like Google or Facebook, but it's architected by a guy called Evan You. You can kind of see sort of the popularity of these things over here on the right. I've just kind of counted up I didn't count them. I just read it off the GitHub webpage for these guys. The number of times that these projects have been starred by people who think they're cool. You can see here that Angular is kind of less popular than the other two frameworks, and React and Vue have had pretty near parity until kind of this year, when Vue has kind of stepped into the lead in terms of people's willingness to star them on GitHub. That said, these are all very, very capable frameworks. I've actually written non-trivial applications in all three. And my take on these different alternatives is kind of summed up here along those two axes that we were talking about over here. So I would judge Angular to be opinionated. In other words, my way or the highway. Here's how you do application development. If you don't like that, don't use our framework. And comprehensive. It tries to be a batteries included kind of a framework that has all of the pieces and parts that you might need to use when you're building a comprehensive user interface for a single page application. And again, when I was using Angular for some projects, I found that to be kind of helpful to get going. Angular was the first of these frameworks that I had learned. And so kind of as a noob to these kinds of frameworks, having the Angular documentation and Angular videos and Angular articles sort of say, here's how you do it, was really helpful to kind of climb the original learning curve. What I found, though, is that as I wanted to integrate things that were a little bit outside of the Angular ecosystem itself, that became kind of problematic. In particular, I was working on some pages that had some fairly complicated forms on them, and Angular, supports the construction of various forms, but it was, didn't quite do what I wanted it to do exactly. And I found that a little bit frustrating because I couldn't just sort of take the form parts of Angular and swap them out and bring something else in that I liked better. The next year, I kind of did these two projects over summers in the last few years. I decided to try React, which is the one from the Facebook people. This is also a very opinionated framework. Here's how you build user interfaces. The nice thing about React, however, was that it was much more interoperable. Angular tries to be a really comprehensive framework for the whole kind of single-page application development process, whereas React, if you go look at their website, I think, it still says React is just about user interface, and that's it. If you want to do other stuff, if you want to do form handling or state management or that sort of thing, you've got to go find that pieces and parts yourself, and we'll work with that. And again, an example was with the form handling. I had to bring in another package that was, and there's about 100 of them that are form packages that work with React that make it easy to create fairly complex forms. But the process of kind of making the tracks all line up and figuring out how to integrate those two things was non-trivial. And I kind of, at that point, I'm kind of longing for the Angular model that had a little bit more of a comprehensive solution. Another thing about React is that it doesn't have any kind of state management. What I mean by that is that as your application gets more complex on the browser, you'd like to be able to keep track of the state of the single-page application. Who's logged in, what permissions do they have, what's in the shopping cart. And what happens is if you kind of distribute that state information to a bunch of different components in the user interface, it's kind of hard to think about how they interact with each other, how do you update them, how do you make sure they're all consistent. And so what's evolved is the idea of a state manager. And in React, that's a separate module. Now they do actually the same team produces a recommended module for state management, but you've got to integrate that into the process. So again, a little bit more work to figure out how to use it because it has that interoperable nature associated with it. But it's I would say my Angular is kind of my least favorite of these three. React kind of my middle choice because they basically say, here's how you make user interfaces, but they don't tell you about how to do anything else. And you can just use other pieces and parts interoperably. And finally, my favorite here, I'll just say that right up front, is Vue. And it takes a different approach to these criteria. First of all, it's fairly indifferent about how you use it, where you use it, what you use it with. It's not really prescriptive in telling you here's exactly how you have to do development. In fact, the Vue team builds it as something that you can kind of adopt incrementally. So if you have a big existing Web 1.0 or kind of early AJAX style application, and you want to start bringing in more modern features and capabilities to the user interface, you can bring in Vue and just replace a part of your website with Vue, and it'll still work just fine with the rest of your existing application. So it's indifferent about how you architect things. Whereas both Angular and React, for example, really want you to use all and only their framework. It's not very difficult, but it's more difficult to integrate a partial migration of an existing website into using one of those other two frameworks, whereas Vue kind of starts from the assumption that you're not going to just abandon all your existing code and switch everything over to Vue at great time and expense, but that you'd like to be able to incrementally adopt Vue into your environment. On the other hand, Vue tries to be a little bit more comprehensive. So for example, with the idea of state management, the Vue team has also produced a module that does state management that you can wire directly into Vue, and it works really easily. It doesn't require a lot of configuration. It just kind of works out of the box in a way. It's a little bit more of a batteries included approach. That said, I think they also have struck a nice balance between being really prescriptive about what you have to use with Vue and allowing you to adopt other solutions for different parts of the application architecture. So that would be that is my choice personally for doing user interface development in a single page application, and that's what we're gonna explore in here. Hopefully that provides you with some background on kind of how to select these kinds of things and what the options are. You may have used some of these other frameworks at an internship or just because of personal interest. They're all very, very powerful, very, very capable, and I'm recommending Vue because I think it sort of hits a nice sweet spot that is easy to use, fun to develop in, fairly straightforward to learn about, which is obviously a key criterion here, and that we'll be using that going forward.